Okay, here we go. Number 2, your second lesson today to go with whatever we're working on. We are looking at line segments and distance, where you will calculate and find the distance between 2 points. So, let's start off, shall we? Let's talk about some things. So, let's start off with this vocabulary. Let's talk about a line segment. A line segment is a line with 2 endpoints. So, that means if I put something like this, A and B, then I have a line segment, AB. And you should refer to that. Don't just say line AB, it's line segment AB, because that's different than if I deal with the arrows. Okay? See, if I put the arrows there, I'm saying line, and that implies that it goes forever. But by saying it's a line segment AB, I'm saying that it starts and stops at A and B. Notice that the first point should be the start point, and the second point should be the end point, whichever order it may be. Now, also, keep in mind that you could even have a line segment within a line and just depends on the notation. Notice the difference in notation. The line above the points, it does not have little arrows on the underneath or on the ends. Yeah, on the ends. Okay. Anyways, also let's make note that, say, we can have points that are in between, and that just means they're in between. They're not exactly in the middle, but they're somewhere lying inside the 2 points, or inside the 2 points that make up the line segment. Yeah, that'll work. All right, so let's find the measure between 2 points. So here we have a line segment, I'm asking for the measure of the line segment EG. Or the measure of EG. So I notice here that EF and EG both, that should be FG. Let's erase that and try that again. FG, whoopsie, make up EG. So that means then if I take the measures between EF and FG, then that should add up to EG. So in other words, I can put this 2 3/4 and this 2 3/4 in place of the line segments, variables or numbers or whatever you want to call it, and then add them together and say that EG is 5 1/2. So 2 3/4 plus 2 3/4 is 5 1/2. If you were to look at another example, we're going to find AB. But notice this time B is in the middle, or B is in between A and C. And I'm telling you here that AC is 13.2. So if you take notice, AB and BC add up to AC. But when I put the numbers where they go, the 13.2 goes in place of the AC, the 5.8 goes in place of the AB. So this is like where we do some basic algebra and we solve by subtracting, because we would have added these 2 segments together to get this one right here. So I can subtract, kind of undo, to find out what the other one, what the other little one is going to be. So AB here is equal to 7.4. And if you, we'll go from there. So AB is equal to 7.4. Okay, so I should get used to the idea. Keep in mind that if I start looking for these, that I'm just going to, like, when I find the measure, I'm not going to have the line segment over it. I'm just doing the line segment, the line over it, as I'm trying to identify what segment is what. All right, so next, let's find another distance, but this one's going to be, find it like the value of an A. So here we go. Notice here that XZ, the whole line segment, is the same as XY and YZ. And then put these two together. So this right here, 5A minus 4 is XZ. 3A is XY. And then YZ is 14. So what does this look like? Well, this looks like what we do when I told y'all, variables to the left, numbers to the right. So I would move the 3A to the left. If it's positive, it would become negative. I would move the minus 4 to the right to join the 14, and if it's minus, it becomes a plus. So now I'm saying I have 2A is equal to 18, so divide by 2, A is equal to 9. So here we go again, doing some simple algebraic properties. All right, on this one I'm just going to put it up as is. Congruent segments are line segments that have the same measure. Keep in mind, I also wanted y'all to start using the correct terminology, so try to use that. Distance, as we've been saying, is the measure between 2 points of a line segment. Now, no matter who's first or how you want to put it, just keep in mind that it's always going to be the absolute value. Distance is always going to be like a positive number unless I state otherwise. So we're always going to have these absolute value signs. So kind of keep that in mind. So even if, like, say you get a negative answer, it should be positive. So there will always be these absolute value signs. Distance is defined as being the, it's just a measurement. So there is no negative distance per se. All right, so now how do I solve or get one that's diagonal? Because this is horizontal. This is easy. I can just count and go, oh, okay, I can do this and say this and whatever. But what happens when it's 2 points that are diagonal? Well, y'all did the Pythagorean theorem where you said, like, okay, if I have 2 points, I can say, you would tell me, like, a plus squared plus b squared equals c squared. Well, what does that mean? That means technically this. If I have 2 points here, there is a distance between the vertical up and down, and there's a distance for the horizontal left and right. And then if I work those two together, that allows me to say, get this right here. So in geometry, we do the distance formula a little bit different. We don't say a squared plus b squared equals c squared. We say basically that that distance is equal to this square root. It's a slight change off the actual theorem itself and what you're used to seeing in algebra. But all it is find the distance between the x's, square that, plus find the distance between the y's, square that. That helps us get rid of not worrying about the absolute value, and then take the square root of those two, the sum. For example, we're going to find the distance if c is equal to a certain point and b is equal to a certain point. So identify what's x and y, and then you're going to say square root. Okay, so notice here how I set this up. I go ahead and set it up just like this. Every single time my distance formula, I would set up just like this, and where all I got to do is put the numbers where they belong. So x's are in the first one, so I would put 5 and -4. Y's are in the second one, -1 and -6. Now, of course, the minus negative becomes plus, and the other one minus negative would become plus. So I'd end up with 5 plus 4 is 9. I'm going to square that. -1 plus 6 is 5. I'm going to square that. 9 squared plus 5 squared is 106, and then I'm going to take the square root. Now, if you take the square root of that, it doesn't come out even. So this would be an irrational number. So you can leave the answer just like that, or you can give it to me as a decimal, approximately 10.3. And we'll discuss what that squiggly equals sign means later. Anyways, that's it. Short and sweet. There you go. We're done. If y'all have any questions, make sure y'all ask in class. But thank you so much for your time. Y'all take care.